right, so before we start today, we've got a few folks from CornHacks. It's an annual hackathon that's been going on for, I think, 7, 8 years or so. I'm the current faculty advisor for it, and it is a really great opportunity. It's a little bit later this year because we had to move locations, but we've got some folks here to talk about it, and we've got up on the screen here a couple QR codes if you want to look at those, or on the live stream. You can go ahead and get more information about it. Go ahead.
Yeah. Hi guys, we are CornHacks Hackathon, the organization this year. So today we come to introduce you guys about the competition.
Yeah, so a little bit more about CornHacks. It's going to be on March 1st and 2nd this year. It's 24 hours. And the idea is you can be individually or with a team of up to 4 people, and you just get together, make a project. We have a theme. You don't have to follow the theme, but our theme this year is CornHacks and Corn Odyssey. So it's like futuristic based. So you make some futuristic program, you have 24 hours, and then at the end of that, judges will judge it, and then the top prizes, or the top teams will get prizes. Everything is free here. Everything's paid for by industry sponsors, so it's also a really good opportunity if you're looking for an internship or something, because all the companies will be here. They're all looking to see what UNL has for talent. And so yeah, food's free, food's provided, everything's free. So yeah, come and have a good time.
And we have the QR code for the website on the right, and then the Instagram on the left here. So on the website you'll find like the day, you'll find like the location, you find some other pictures from last year's CornHacks, and yeah, if you just need to ask questions, you can always reach out to us or go on through the website, and yeah.
Thank you guys.
All right,
Yeah,
thank you.
sorry.
Yeah, go ahead.
Oh, sorry.
Yeah,
By
go
the
ahead.
way, I'm your ally in this course, so if you have any question about that, you can come and ask to my office hour. My name is Owen, by the way. Thank you.
Thank you. So again, CornHacks, it's going to be in March 1st and 2nd. Again, it is a really good opportunity. They've got some great prizes. Last year they had iPads and for the Legos, and this year hopefully they're going to get even more Legos. So go ahead and register for it. You do not. I mean, you're freshmen in here. This is your second semester, but don't take that as I'm not prepared to do it. There are plenty of teams that that have put together some amazing projects even in their first year, and even if you don't intend on winning or going for that grand Lego prize, it is a good experience, and it's free food, and it's also a fun hangout. This year it's in Kiewit tentatively, so the brand new building over in engineering. All right. I'll also post all that information onto CampusWire so that we have it. But otherwise, I wanted to continue with our isotope demo here. Just to refresh our memories, what we're doing is we're reading in an isotope name, strontium 90. It has an initial mass, 10 kilograms or something, and it also has a half-life. In our case, it's going to be 28.9 something years, right? And then we produce a table that looks something like this. After the first year, you only have 9.76 grams left, grams or kilograms, whatever it is. But after 29 years, you now have less than half of the original mass. Now it hasn't evaporated, it's just decayed into other radioactive products, or eventually it'll decay into a stable non-isotope element, right? And so we went through and we did what's called an imperative style, right? There is no object-oriented programming here at all. Imperative means that you have line 1, line 2, line 3, and it executes one after the other. Right? There are no objects here. What we're going to do is we're going to start looking at object-oriented programming and how it is fundamentally different than what you're used to, either in C or probably in Python. The Python way of doing things that you probably were presented was more imperative rather than the functional style that is preferred by Pythoners. But in any case, we're going to start looking at this more object-oriented. Now, the first step is, like I said, I don't see any objects here other than the class that I put this demo class into, okay? So what I want to do is I want to go through and I want to first start, like we said at the beginning of class, that this entire course, that instead of a top-down solution like we did right here, we're going to go with a bottom-up solution. The first question that you should ask yourself is, what classes or what objects should I create in order to model this problem? We already went through this with books, right? We said, well, how do we represent a book? And we designed a book class. And then we found out, wait a second, how do we take care of the author? That's 2 pieces of data. Let's go ahead and create a person class. And then we got down to the dates, right? The read by date or the release date, whatever it was. And we said, well, wait, what is a date? Well, a date could be a string, an ISO 8601 string, or it could be a collection of 3 numbers, or it could be something else. And we decided that that was yet another class. Fortunately, it was already built into Java. So, ideas here. How should we start? What is our first class? What is the first object that we should design to support this idea of computing an isotope decay table for a radioactive isotope? So what kind of class would you do? Hopefully you're doing it, or you've already done it for your assignment 0 there, right? That you've already designed a class to support and model that running data, right? What would you do here, though? No? Well, I want to create. What are we doing? What does it say? What does it say on the tin? An isotope. What is an isotope? An isotope is a name, mass, and half-life. That should be screaming out to you. 3 pieces of data. What do you do with it? You wrap it up into one logical unit. Let's go ahead and create a new class, isotope, right, to represent an isotope. And is it going to have a name? It's going to have a half-life, so double half-life, and it's going to have a mass, okay? Now, we're going to go through and once again, like we did with the book class, like we did with the person class, we are going to put in all of the boilerplate stuff. I'm going to make all of these private variables, right, because I want to protect them from the outside world. CRUD, I need a way to create isotopes, retrieve their data, maybe update their data, and finally destroy their data. Remember that that is CRUD, right? That is going to be create, retrieve, update, and destroy, okay? So let's support all 4 of these things, and we'll go through one by one as a review. Create, how do you create an object? You're going to be doing this in your lab next week. It's called a constructor. And the way that you do that is you go up to source, generate constructor using fields, and I will generate I will use all 3 of those pieces of data, okay? All right. So I take the name and I set this isotope's name to that name, half-life, set that the half-life, and then set the mass, all right? That's a way to create something. Now let's come back over here and use it. So once I've got those 3 variables, what I'm going to do is I'm going to create an isotope instance. Isotope. Now it's not always going to be strontium, right? Strontium is the one that we were using as our test case. I'm just going to call it isotope, right? As equal to new isotope. Remember that the new keyword invokes the constructor on it. We'll come back to why it's not compiling here in a second. But style note here. This is why all of our classes are upper camel cased, right? Because if we ever have need to have a variable of the same name, we can distinguish these 2 things by saying, well, that's capitalized, so it must be the class, and this is lowercase, so therefore it must be the instance of a class, a variable of the class. Now, why is this not compiling? As you're going to find out in your lab next week, right? If I don't have any, let me go ahead and get rid of it for now. If I don't have any constructor, one default constructor will be provided for me. Now it is compiling, right? Because if you don't put any constructor in, the default no argument constructor is automatically created by the language. But the second that you define any other constructor, right, then you no longer have access to this default no argument constructor. You can go ahead and create it if you want, right? Let's go ahead and create that default no argument constructor. Isotope, no arguments, no parameters there. And what should we do? Like name is equal to, like this dot name. This dot name is equal to What should I set that equal to? What's a default value for the name of an isotope? There really isn't a default value. So null, right? What about half-life? This dot half-life. Right? I'm going to set that equal to another default value here, 0. And finally, the mass. This dot mass is equal to 0.0. Right? Now, it doesn't make all that much sense to be able to call this constructor, right? But if you ever wanted to, then you can go ahead and restore it. So if you don't define a constructor, the default no argument constructor will be provided for you. If you do define a constructor, it goes away. But if you want to define that constructor, then you can go ahead and restore it. You can have as many constructors as you want. Okay? I'll go ahead and leave that in there. Okay? By the way, this does not require documentation, and these two constructors do not require documentation. But the class should have documentation. Represents a radioactive isotope. Right? Okay? Radioactive, 2 words? I don't know. That's not... It should be 1 word. I'm not sure. Anyway. All right, so we're done with create. Done. What about retrieve? And by the way, I'm not using it over here. Let's update this code here to isotope name, initial mass, and half-life. Or I guess it's the other way, right? It's half-life, then mass. Half-life, then mass. So half-life, then mass. Okay. All right, so I've been able to create it. Yeah, go ahead. Null is what I would go with. The default value, I don't know, would be 0, which would probably be, that is an instance of time that I don't think actually technically exists between, -1 AD and +1 AD, because there is no year 0, right? So that could be another thing that you did. All the numbers would end up being 0 in that case in the string, but if you created it, I don't think you could even do that. I don't think you could get away with that, right? So local date foo is equal to local date dot parse, and we'll go ahead and go with 0, right? And let's see if this even allows us to do that. Nope, you're not even allowed to do that. So therefore, null is your answer. Okay. Or I guess you could put like the first second of the first day, like 0, years 1 or something like that. January 1st, year 1. But no, null is much better because it says I don't know what the date is. All right, what about retrieve? Well, we went through those exercises too. I'm going to go ahead and generate getters. I'm going to select all the getters and generate them. So that if you ever want to know the name of this isotope, you can get it. If you want to know the mass of this isotope, you can get it, et cetera, et cetera. Right? All right, let's come back over here and update this code so that we're using that now. Actually, no, first of all, before we do that, let's go ahead and do another retrieve here. Right? That retrieve will be a 2-string method. It's kind of like a retrieve because you're trying to print it out. Right? I don't like that. Let's go ahead and steal this formatting over here. Right? This formatting. And we'll return, instead of returning that default auto-generated code, I'm going to return string.format, this format right here. It's going to be, actually I like it a little bit better if we put the name first, and then in parentheses maybe we'll put the mass, kilograms, and then the half-life of blank 2 years, half-life. There. And so this dot name, this dot mass, and this dot half-life. Oops, and I need to restore it. I was too zealous in my deletions. There we go. Right. Half-life of that. There. So that over here, I can now replace this piece of code here with println isotope. Right. Let's run it again. Right. Oops. Format specify. I screwed up. What's wrong with it? Oh no, I wasn't overzealous there. Half-life. There we go. Now I've got 1, 2, 3, and I should have a closing parenthesis there. All right. Now let's run that again. There. So what have I basically done? I have given responsibility of formatting the string, the output string of this object, and where have I put it? I've put it inside the object right here. That's what should happen, right? Book stuff, where does it belong? In the book class. Person stuff, where does it belong? In the book class? Nope, it belongs in the person class. Isotope stuff, like formatting a string output of an isotope, belongs in the isotope class. Just keep saying that to yourself over and over and over as you design your stuff starting next week. Where does this belong? It's an X thing, therefore it belongs in the X class. Okay? All right, so we're done now with retrieve, right? Let's update the rest of this code here. The current mass is equal to the initial mass. Current mass, what I'm going to actually do is I'm going to change that so that it is the isotope dot get mass. Right? We're getting the mass of the isotope itself. And then I'm going to change that here as well. Update the current mass and update the current mass, except that it's not going to let me do it on this line. Right? It's getting the mass. I can't set that to the new mass here. So let's come back over here and think about how we could do an update. Right? Let me go ahead and generate a setter. Let me generate all the setters and see what they look like. Okay? We'll put them all right here. I could set the name, I could set the half-life, and I could set the mass. I probably want to set the mass for now, but what about the name? Does the name of an isotope change? It's strontium. Does it? I mean, you could say that it decays into uridium or something like that. But no, I don't like the ability to reset the name. What about the half-life? Is the half-life of strontium going to change? Not unless the fundamental laws of the universe change. Right? So I'm going to get rid of that. But for now, I do want this ability to update because I want to set the mass over here to the new mass. Set mass, new mass. Do you see as I'm going through this process, I'm not actually changing the functionality of the program. The functionality of the program stays the same, but the style and the paradigm in which I'm programming it is becoming more and more object-oriented rather than structural or procedural, right? In other words, the imperative style of do this, then do this, then do this. I am communicating with an object here called isotope, okay? In fact, let me run it and show you that it doesn't change, right? It's exactly as before. The functionality has not changed at all, okay? All right, that's create, retrieve, update. What about destroy? I need a way to delete this isotope when I'm done with it. If I were in C, what would I have to do to that isotope? I'd have to free up that isotope because it was memory or something. We don't have that in Java, nor do we have it in Python if you're coming from a Python background, right? Instead, what happens to the object after we're done using it? It gets automatically created, or it automatically gets cleaned up, garbage collected. So destroy, not possible in Java. Right, good. We've taken care of everything here, okay? All right. Again, all of these things none of these things require documentation as far as this class goes, because these are all trivial methods. What would you say if you tried to document this function? Returns the mass of this isotope. Right? You end up writing more than the actual function name. The function name tells you what it does. It gets you the mass of that object. Right? So that's not necessary. Okay? All right, but I want to take this a step further. So far, our book class, our person class, our isotope class there, so far all they are data objects. They just contain data objects, constructors, getters, and maybe a toString method, maybe a setter in this case. Okay? What I want to do is I want to change it so that it now has behavior. Take a look at this line where I'm decaying it by 1 year. Right? That's kind of complicated, right? Because actually I'm doing it in 2 lines here. I'm calling this complicated math function. It's not that complicated, but it's complicated enough that I would ask myself, what is it doing here? It's decaying the mass by 1 year. Right? That sounds like a what thing? Fill in the blank for me. It sounds like a function, certainly, but the functionality itself. Is it a person thing? No. Is it a book thing? No. What is it? It's an isotope thing. So therefore, where does this belong? In the isotope class. Let's move it over to our isotope class. And we're going to have our first non-trivial function here. Public void decay. Right? And now we do require documentation on this one because it does something special. It doesn't just get you something, it doesn't convert it to a string, it does some functionality. It does what we call behavior. Right? Decays this isotope by 1 year. Right? I'll go ahead and come back to that with a question mark there. Okay? Decay it by 1 year. So now we don't have to get the mass. We can say this dot mass. Right? There's still 1 year. This dot half-life. Right? And this dot mass should be equal to the new mass. Equals new mass, or mass. Now my question is, can I simplify this even further? Do I actually need that new mass variable if I'm just going to compute it and set it? Okay. So I'm going to set it in one line. There. Even simpler now. But now it's doing decay stuff. Decay stuff is an isotope thing. It belongs in the isotope class. And now it's in the isotope class. Over here, how would my code look different? Instead of that code that I just erased and moved over, I would say isotope.decay. Okay? Now let's see, did we change anything? Did we break anything? Nope, it still has the same decay table as before. But it is more object-oriented programming. The details, how do you decay an isotope for 1 year? Right? Well, it's in that function now, and it's in the proper class. Right? We know that it's going to be this formula that I gave at the very beginning, but do we have to worry about that outside the class? It just gets a job done, right? Here's another example. Have you ever wondered how the math.square root function works? Right. Oops. There we go. How does it compute the square root of 2? Right. Iteratively? Okay. Maybe. I don't know. What's the real answer? Did you ever worry about it before? No, you never cared about it. So who cares? It just gets the job done. That's what's called abstraction. In this case, it's procedural abstraction because there's a function here that does some complicated stuff, but we never have to worry about it because it's in the function. Now, if you do need to write the function, then yeah, you need to go and see what it looks like. And there it is. Right? So it's about 100 lines of code to do it. In fact, yes, it is an iteration. It's several iterations, right? It's a whole bunch of if-else statements, right? Normalize X, and then we've got a bunch of bit masks, a bunch of bit shifts. That's a cyclic shift, I think. I'm not sure. And then we've got unbiased exponent. What the heck is that, right? Then we got another shift there. Then we've got a while loop, and there was a for loop in there somewhere, wasn't there? I saw, yeah, there's a for loop, right? So about 100 lines of code, 120 lines of code. Do you want to have to worry about those 120 lines of code anytime you want to compute the square root of something? No. That's why you take those 100 lines of code, you put it into a function, and you never worry about it again. Right? There. How does decay work? I don't know. But once we've written it, we've put it into a function inside the class, and now it works. So I want to come back to this question mark here now. 1 year, okay? That means that I should have decay by 1 year, right? Because that's what it says on the tin. Well, what if you wanted to decay it not by 1 year, excuse me, there we go, but what if you wanted to do it by 1 month, right? 1 month. Now, instead of a year, what would you do? 1 divided by 12 is like, what, 0.125? Something like that. And now it's by month. What if you wanted to do it by 1 minute? Because there are some isotopes with half-lives of fractions of seconds. They decay almost immediately. And I want to support that. 1 minute, 1 second, 1 nanosecond. Should I be copy pasta, copy pasta, copy pasta? No. Let's go ahead and do one of these things. Decay by some amount, right? By some amount. There you go. Some amount. Now you tell me, what should that some amount be? What if I did it like this? Double unit, time unit, or whatever. by unit. Right? Does that tell you that it's a year? Now it's a I can actually do a fraction, right? What I can do is I can say decay it by 1 year, or decay it by 1 year and 6 months, or decay it by, I don't know, 1 month and 1 day. So 1 divided by 365, right? Or 365, something like that, right? But does that tell you, does it say that in the function? I could put that into a variable name by the year given, right? And this could be 1, it could be 1.5, it could be whatever, right? But that means that I have to read the documentation and I have to read a variable name to understand what that unit is. Is there a better solution? I have a concept of a duration of time or a period of time. Right? I have a concept. What should that be screaming out to you? Use it. In other words, create a class. Right? Now, date time, that's like an instance in time, though. Right? That's like today. That's not a duration of time. Instead, we would either use duration, or better yet, we'll use period. Right? Period. There's a period of time here that is part of the Java time library by the given period. Right? And you can actually get fancy with your documentation if you want, and you can say link, or this should be an @ link to period. Right? The reason that you'd want to do something like this is because when you look at your documentation, it now becomes a hyperlink that takes you to the documentation for period. Right? Or if you want to, you can go ahead and jump to it and read all about it right here. Right? We're not expecting this, by the way, in your stuff. Right? If you want to go ahead and start using proper doc style, full to its doc style comments to its fullest, go ahead. We're just expecting doc style comments. Okay? Not by 1 year anymore, but by the period. Uh-oh. What do we do about this now? Because that should be in the in units of years. Right? We're going to have to do some of our own math now. Period dot get years. Right? Double years is equal to get years. Now this is actually an integer, and we have to actually pay attention. The concept of a period is actually years, months, and days. So we also need to get the months. Years plus equals period dot get months, right? Divided by 12.0. There we go. Oops. There. All right, so I'm going to take months, which gives me like 5 months. I'm going to divide it by 12. Why? Because that's the fraction of a year it's in. It can actually have more than 12 months in this period. You can have 1 year and 13 months. And it will give you 13 out of this, and so it'll give 1.128 years or 25 years or something, right? Now that now there's also days. Years plus equals period dot get days, right? Divided by how many days in a year? Careful. 0.25 because of leap years. Actually, it's 0.24 something 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 and change, right? But we don't care. We just want an estimate here, right? Why did I go 0.0 and 0.25 here? Well, I did put 0.25 because of leap year here. But why did I go 0.0 there? What do I risk if I just do divide by 12? Truncation. And indeed, the number of months is an integer. It's really small there, but you can see it. Integer divided by an integer is going to be an integer. So make sure that you are taking care of truncation there. Right? All right, now I've got years divided by that. And now I can support decaying this isotope by 1 year, by a half year, by any period that I want. Okay? And in this case, I'm going to have to create that period. So period, 1 year, is equal to period dot of 1 year, 0 months, and 0 days. And when I pass that in, right, there, all the details of extracting how many days or what fraction of a year that actually is now in here. Right? It's all taken care of by my class. Okay? That is a fundamentally different way of programming than you're used to. You have to ask yourself, what objects do I define? In our case, we defined isotope. What state do you need to define? Well, it's a name, a half-life, and a mass. What behavior do you need to define? I want a function to be able to decay it by any period of time, right? Cool. And it didn't change any of our functionality over here. It just made it more object-oriented, right? All right, so let's start talking about that in a more formal manner here. A reminder that Java is a class-based object-oriented programming language. And what that means for us is that everything in Java is a class or belongs to a class, right? So everything up till now is like in your first assignment, you're just making static methods, and you put that into a class that we specified the name of. But now we're actually going to write real classes with actual state and behavior. It allows you to model a real-world object, or what sometimes we just call these entities. Okay. Now, what are objects formally? Objects have three aspects. One is identity, the other is state, and the other is behavior. Okay? Let's come back to identity here in a second, because we've already done state and behavior. A state is the collection of properties, also called elements, attributes, data, fields, or I'm going to use the term member variables here to define what the state of an object is. What is the state of the isotope object? Its member variables are name, half-life, and mass. Okay? Behavior is the functionality that acts on that object's state or state or data. So what the object does or what the services it provides. In other words, its methods. Right? So what are the methods over here? These, as I said before, these are kind of trivial methods. That's boilerplate stuff that should be there anyway. What really counts here is this method right here. That's its behavior. That's the behavior of the isotope. An isotope decays by some period of time, right? Okay? And it updates its mass here. By the way, do I need this setter anymore? Are we using it over here at all? Nope. So you know what? Let me go ahead and get rid of it. Okay? I'll leave it in there, and when we post the notes, it'll still be there, but it'll be commented out. When you turn in code, do not do that. That is cruft, right? Get rid of it entirely. Don't comment out big giant chunks of your code just so that it compiles and you don't want it anymore. If you don't want it anymore, get rid of it. Right? Remember, it's called cruft because Cruft Hall filled up with garbage that nobody wanted. Instead of throwing it away properly or recycling it properly, it just filled up with garbage. Right? Don't do that. Now let's come back to identity. We actually saw this before. Do you remember when we were doing the book demo? And we had a problem with our last report, right? Not this one, book demo right here. There we go. This last report where we created a map, right? And I can run it again. And it was like the Haruki Murakami books, right? There were 3 of them. But the problem was initially there were 3 instances of Haruki Murakami, right? With each of his 3 books. Right? That's because we never defined what identity is. An identity is an aspect of an object that distinguishes it from all other instances. We solved that problem by going into the person class and defining these 2 functions right here, equals and hashcode. This defines identity in Java. That this object is equal to that object if they're the same thing in memory, or if the first name of that object is equal to the first name of that object, and the last name is equal to the last name of the other object. That's what identifies identity there, the equals method. The hashcode method is also a necessary condition for the equals method here. If you do one, you got to do both. Okay? So identity is through an equals. Let me put that in the notes for you. Identity is achieved in Java by generating the equals and hash code. Hash code. Is it capital C? Yes, it's capital C. Code methods. Achieved. Did I spell that wrong? Achieved. Okay, there we go. All right. So all you have to do is generate those 2 using your IDE. Right? Communication between these objects is done by something called message sending. Right? It's just a fancy way of saying I'm going to call that method's objects. or methods, or I'm going to call that objects methods, excuse me. How did we do that over here in the isotope demo? I had an instance of an isotope, and what did I do? I called its function, passed it 1 year. Right? I was sending a message to this isotope to decay yourself by 1 year. Right? And that's just a fancy term called message sending. You're just calling methods, right? Don't worry about it. Communication is facilitated by an object's interface. The interface is the public methods that are available. Okay? I could have restored this set mass here, and I could have made it private, there we go. Right. And then I could use it down here instead. I could say this dot set mass equal to this dot mass, all that stuff. Right? Okay, I could have done that. But is this part of the public interface? Can I do that over here? Can I just set the mass willy-nilly? Isotope dot set mass to -10? Right? I'm not able to do that because it's not part of the public interface. This is where those keywords public, private, and eventually protected come in, right? Private methods may be useful, but are not part of the interface, the objects interface, okay? As we've also seen, objects are constructed instead of just assigned, right? In Python to an extent, and definitely in C, you can only assign values, right? Int x is equal to 42, or in Python, x is equal to 42, right? You're just assigning values. You don't actually create values. They're built into the language. But here in Java, we have to create constructors for our user-defined objects, right? Constructors are methods named after the class. They have no return value, as we've seen before, and they can take any number of parameters. You can define a constructor, a no-argument constructor. If you don't define a constructor, a no-argument constructor parameter is provided by Java. Okay? However, as we've already observed, if you do define a constructor, the default constructor goes away. You can always redefine it explicitly if you want to. Okay? You can have as many constructors as you want. Right? Here's a useful pattern that we'll end with, or maybe depends on how long it takes us. Useful pattern are copy constructors. All right? Okay. Let's come over here and witness what that means. What I want to do is now we have another sample of the isotope, right, with a different mass. Right? Say it's like 20 kilograms instead of the original 10 kilograms that we started out with, or grams or whatever, right? What would I have to do? I just have to say isotope, new sample, so sample B, right, is equal to new isotope. And then I would want it to be a copy of that other isotope, isotope sample A, if you wanted to rename that, dot get name, isotope dot get half-life, isotope dot get mass, but I don't want a copy of the mass because now it's like 4.97. I want to have it be 20 kilograms, right? Okay? That was a lot of typing, right? In fact, let me go up here and rename this. Remember our tricks? If you need to rename a variable, you can go to refactor, rename, isotope A. Did I have to type everything and change it in every location? Nope. All done for me, okay? So now I've got isotope A being copied into sample B. Oh, I should have called it sample A. That's okay. Who cares, right? All right, but I don't want to have to type that out and type that out because what I'm doing is I'm kind of breaking what's called encapsulation. We'll define that later. I'm ripping the object open, pulling out its guts, its name, and its half-life, so that I can give it over to another object. In order to create a new isotope, creating a new isotope, that sounds like an X thing. It belongs in the X class. Fill in that blank for me. Isotope, right? So let's come back over the isotope class and give ourselves another constructor. You can't generate these automatically, so I do have to type it out. Isotope that takes another isotope, right? Isotope, right? Or that, if you want to call it that. Don't call it that, isotope, right? And then also double mass, right? okay? And what it's going to do is it's going to say this isotope's name is equal to that isotope's name. I'm going to copy over the name. This dot half-life is going to be copied over from that isotope dot half-life. But this dot mass is going to be equal to the mass that you just gave me, because I want a second sample of a different mass. That saves me a whole lot of typing over here, right? Isotope, right? Much simpler, much better, right? And isotope things are now in the isotope class. It was, sorry, isotope A. There we go. You've seen this before. We just didn't call it a copy constructor. List of integers. Foo is equal to new array list of integers. Foo.add 10. Foo.add 20. Foo.add 30. Right? Now I want a different copy of foo. So I'm going to call it bar. Not foo bar, but bar. Let's go ahead and bring that in. Okay? But I want to copy over each one of these. So should I write a loop here to say, for each element in foo, copy, add it over to bar? I could do that. For integer x in foo, bar.add x. Right? 3 lines of code. Why do 3 lines of code when you can do no lines of code? Right? Foo. Right? What is that doing? It's taking another list and it's copying it into this list over here. Let me show you. System.out.println bar, and we'll also print out foo. Foo and bar. Right. There. Now I've got 2 copies of the same list. I'm going to prove to you that they are what are called deep copies. They are completely separate copies. Because if I were to say bar.add 42, does that add 42 to the first list? Nope. It's a completely different copy. This is a copy constructor. It's taking another collection and copying it into this collection over here. We also saw this with sets. If you want a set of integers, right, unique, is going to be a new hash set of a copy of foo, right? And I don't know, system.out.println unique. There. And I need to bring all these in, so import and import, right? Import that again, right? When we covered sets, lists, and maps, you can see that it's now a set, right? And it's unordered, 20, 10, and 30, right? And if you had 2 30s in there, right? Then in the set, you no longer have in the list you have 2 30s, but in the set you only have unique elements. Copy constructor. Really, really useful pattern. We'll talk about patterns later on, but if you want to, give yourself a copy constructor. Eventually in your, it'll really come in handy, trust me, in your project, all right? So some common things that we've talked about before, YAGNI. Do you remember what that stands for? Actually, let's do DRY first, DRY. What is the DRY principle? The dry principle? Don't repeat yourself, right? The whole reason that we do objects is that we don't that we put it into an object and we can reuse that object. We don't have 50 different persons. We have one person class and 50 instances of the person class. What about YAGNI? You ain't gonna need it. All right. In other words, don't over-engineer. Engineer your classes. For example, think about what you're doing right now. Right? How many people are creating a class to represent a data point in the run data? All right, hopefully by the end of the day, everybody's hand is up because you're going to want to do that, right? But what should it have? What does your data point have?
So the time.
All right, the time. And what else? Latitude, longitude, and elevation, right? 4 pieces of data. You might think to yourself, wait a second, latitude and longitude, that's 2 things that are kind of related, right? So maybe I should create a location class to hold those 2 pieces of data so that now I've only got 3 pieces of data and those 2 pieces of data are over there, right? You have now over-engineered it. YAGNI, you ain't gonna need that, right? keep it simple, right? That's the other acronym, right? Keep it simple, stupid. Keep it simple. Stupid. Just remind yourself, don't call yourself stupid, just say it's KIS instead, right? Although that's not as impressive, whatever, I don't know, right? But keep it simple, all right? Keep it simple. I said simple, there we go, 2 simples, right? So the second one, you don't have to call yourself stupid, just emphasize simple. Keep it simple, simple, right? Something like that, right? Anyway, those are some nice acronyms to remember as you are designing, especially for the first assignment, but especially for your project starting next week. Right? Any questions? All right, then. Good luck on your first the assignment 0, which is due at midnight, and then we'll come back on Monday and start talking about technical writing.